Welcome to Dimensional Analysis Part 2. This is Mrs. Rutschling. In Part 1, we learned how to use conversion factors to convert something to different units. And let's practice a word problem. So go ahead and give this a try. If we look at the problem, we have in red, we have 91,000 seeds for 1 pound. That's a conversion factor. 200 seeds per cone, another conversion factor. Our 1 pound to 454 grams is given, that's a conversion factor. And so our given to start with is 1.00 kilograms. If we look at our conversion factors available to us, we have seeds to pound, seeds per cone, and pound to gram. But we don't have anything for kilograms, so we need to start by changing kilograms to grams using our conversion factor. Once we have grams, we can use this conversion factor, which is an equality in the problem. That gets us to pounds. Now we can use some of the conversion factors found in the problem. We have 91,000 seeds per pound. And now that we have seeds, we can use the blue conversion factor, 200 seeds per cone. And that's going to give us a value of 1 times 10 to the 3 cones. Notice that our starting value has 3 sig figs, and so our ending value has 3 sig figs. Sometimes our given that we'll start with has 2 units, so we have to make sure that we put part of it, the one that goes with the number here, on top, and then whatever's behind the per, or if there, you could also write it 50 miles per hour. Make sure you don't put both of those units on top, but that 1 hour goes on the bottom. We need to convert both miles into feet and hours into minutes. Let's start with hour. Doesn't matter which one you start with. But I know that there are 60 minutes per hour, so then I can cancel the hour. Then I'm going to tackle the miles, and you don't have to memorize this one, but it was earlier in the lecture in part 1 that 1 mile is 5,280 feet. So now I have feet, and so I have it feet and minutes. I'm done with my conversions, and now I just need to calculate. I have 4,400 feet per minute. I started off with 3 sig figs. So I need to end with 3 sig figs. There's no way to round this to 3 sig figs. So I use my handy dandy scientific notation, and now I have 3 sig figs. We have one more practice problem, so please pause the video and give this one a try. We know that 65 meters per minute is going to be a conversion factor, and so our 8,450 will be our given that we start with. I have feet, and I need to get it to meters. The only conversion that I know from English to meters is 1 inch equals 2.54 centimeters. Now I have feet, so I need to get it to inches, so I'm going to use that common value, 12 inches for 1 foot. And now that I have inches, I can use my conversion to get it to centimeters. I also need to get to meters, so I'm going to use the centi. So I have meters, but I need to know time. And so I need equality is 65 meters equal 1 minute. So I can use that to go from meters to minutes. And lastly, I need to go to seconds, so one more conversion. I do my calculations. Remember, you can calculate across the top and divide by the product of the bottom, or you can do 8,450 times 12 divided by 1 multiplied by 2.45 divided by 1, and so on. 3 sig figs for my starting value, so my answer has 3 sig figs. If you have any questions about dimensional analysis, please bring them to class. We're going to look at one more conversion factor. Earlier in this chapter, we calculated density using the formula. This time, we're going to use it as a conversion factor. And you will be asked to do some problems this way. We're starting off with 68.4 grams. If density is given in a problem, that means you're going to use it as a conversion factor. So I'm going to start then with my mass in grams. I'm going to use the density as a conversion factor to get it, in this case, to centimeters cubed. It's asking for volume, and it's a liquid, so I'm going to also change it to milliliters. 3 sig figs seems to be the common today, but they're not always. And here's 3 sig figs. Okay. And here is density used as a conversion factor. So remember, if it's given in the problem, you're using it as a conversion factor, and you will need on this test to do dimensional analysis for those. Give this one a try. Pause your video. I started with my given 875 milliliters. I used the density as a conversion factor to get it to grams. And then since it asked for kilograms, I used another conversion factor. Let's try one more. Please pause your video. Again, density is in the problem, so I know that it is going to be a conversion factor. I start off with my given of 575 grams. I multiply that by my conversion factor. The 105 grams, that stays with the unit, and it goes on the bottom, and the milliliters goes on top. And then since I need liters, I convert one more time, and that should give me an answer of 0.548 liters. Let's try one more challenge problem. In 1999, NASA lost an orbiter, so we're talking about $94 million, because they didn't include the units. Two groups of engineers didn't include the units. So their calculations were off, and it went too far into the atmosphere and started on fire. So we wanted the orbit to be at 155 kilometers above. One group specified it as 1.55 times 10 to the 5th meters. The other one looked at English feet, 1.55 times 10 to the 5th. And so we want to know how low did it go in kilometers and what was the difference between those two. We're going to start with our given, the 1.55 times 10 to the 5th feet. And if we're going from English to metric or metric to English, we're going to use that 2.54 centimeters equals 1 inch equality. So that means that we need to, change it to inches so we can take advantage of that. So that's the first thing that we do, is we change it to inches. Then we use our conversion factor from English to metric and get it to centimeters. We need to go to kilometers, so I'll change it first to meters and then to kilometers. And I end up with 47.2 kilometers. And then the question also asks, what's the difference in kilometers? So we just find the difference. So make sure you're always reading the problem so you find everything that is required.